And other than that, you solve an inequality just like you would if it was an equation. So I'm seeing that I have x's on both sides and I want to collect them, and I like to collect on the left hand side, so I'm going to subtract 8x from both sides. And an x minus 8x is going to give me negative 7x. I still have a plus 5 there, and that's all less than, this cancels here because we did that on purpose, and I get a negative 16 on the right. Now I want that x by itself, but I have this plus 5 hanging around, so I want to subtract it from both sides. And I have negative 7x now is less than negative 16 minus 5 is going to give me negative 21. Now I need to divide both sides by that negative 7, so I can get that x by itself, remember, and I am dividing by a negative. So I do have to flip the inequality over. So I'm going to rewrite that as x is greater than negative 21 divided by negative 7 is a positive 3. So what we're saying is that x is greater than 3 is our algebraic notation, and we can write also, make a graph. So we're looking at all the numbers greater than 3, so I need to locate 3 on my number line and then shade towards the right end, everything greater than. And since it's strictly greater than and doesn't have an equals part, I will put rounded parentheses here, and then remember those rounded parentheses are going to go right into my interval notation, rounded parenthesis 3 all the way to positive infinity, which is way over here at the end somewhere, and infinities always get parentheses. So 3 to infinity, and that's my shaded region. And then the last thing is to show the set notation. So I'll do the squigglies, x such that, and then I just put in the algebraic notation next and end my set. And there's my 4 forms of the answer: the algebraic notation, the graph, the interval notation, and the set notation.